the discovery that made empty space unstable. For centuries, nothing felt safe. Empty meant inactive. Vacuum meant absence. That assumption was so comfortable, it went unquestioned. Remove matter, remove energy, remove motion, and what remained was nothing at all. Empty space was treated as a passive backdrop, a silent stage where reality played out. To understand why this belief collapsed, we need to revisit how deeply it shaped physics. Space was a container. It held the things that mattered, the particles and forces and fields, but contributed nothing of its own. It was a stage, not an actor. And stages, by definition, do not influence the performance. Forces acted across it, objects moved through it, but space itself did nothing. Clear out completely, and nothing should remain. For a long time, experiments seemed to agree. Remove air, remove dust, remove heat, and systems grew quieter, emptier, closer to true nothingness. The vacuum felt inert, harmless, and stable. But precision changed everything. As instruments grew sensitive enough to probe deeper, emptiness refused to stay quiet. Even in the best vacuums ever created, energy refused to vanish. Tiny fluctuations appeared. Fields vibrated. Effects emerged with no visible cause. At first, these were treated as nuisances, measurement noise, artifacts of imperfect isolation. Surely nothing could still be happening where nothing existed. But the effects persisted, repeatable and consistent. What had been dismissed as noise turned out to be signal. The vacuum was speaking, quietly but unmistakably, and what it was saying contradicted everything that had been assumed about the nature of emptiness. The first crack came when theory made a dangerous claim. If the equations were taken seriously, empty space could never be truly empty. The vacuum itself had a lowest possible energy, but not zero. Something had to remain. This was deeply unsettling, because if empty space carried energy, then nothingness was not neutral. It was active, restless, and potentially unstable. The universe was no longer built on a quiet void. It was built on a background that could fluctuate, influence, and even create effects on its own. The foundation of reality, which had been assumed to be inert, was revealed to be dynamic, restless, and fundamentally incapable of absolute stillness. The discovery that made empty space unstable was not loud or dramatic. It was subtle, mathematical, easy to ignore. But once accepted, it erased the idea of nothing forever. At first, physicists tried to soften the implication. Yes, the vacuum had energy, but perhaps it was fixed. A constant background that could be ignored. Nothing truly dangerous. Nothing that could change. But the equations refused that comfort. The energy of empty space was not inert. It fluctuated, momentarily borrowing energy, producing pairs of particles that vanished almost as quickly as they appeared. The vacuum behaved less like emptiness and more like a restless sea. A sea whose surface was never still, whose depths were never quiet, and whose activity persisted even when every external source of energy had been removed. This created a deep conflict with intuition. If particles could appear from nothing, then conservation itself seemed threatened. But nothing was violated. The rules were obeyed. Energy was borrowed and returned within limits that the universe strictly enforced. As understanding deepened, the consequences expanded. These fluctuations were not just theoretical. They produced measurable effects. Forces between objects shifted slightly in a vacuum. Energy levels changed. Radiation emerged where none should exist. Empty space was no longer passive. It influenced outcomes. It shaped interactions. It quietly participated in every process. This realization reframed stability entirely. The vacuum was not the lowest, safest state. It was the lowest allowed state, and even that state was dynamic. Perfect stillness was forbidden. The laws of physics themselves prevented the vacuum from settling into absolute quiet. Even at its lowest possible energy, the vacuum retained a residual activity that could not be eliminated, a minimum restlessness built into the structure of reality. Emotionally, this was unsettling. Nothingness had always been the baseline. Now it was active, unpredictable, and full of potential. The universe did not permit absolute emptiness. By this point, the discovery had done more than change physics. It had changed meaning. Nothing was no longer nothing. It was something unavoidable, woven into the structure of existence itself. The conflict deepened when physicists realized just how much depended on this restless vacuum. Its energy was not a small correction. It was everywhere, uniform, inescapable. And when spread across the vastness of the universe, its influence became enormous. This buildup revealed a disturbing implication. If empty space carried energy, then as the universe expanded, that energy did not thin out. It stayed constant per unit of space. More space meant more vacuum energy. Expansion fed the vacuum, and the vacuum pushed back. This collided with expectation. Gravity should slow expansion. Matter should pull inward. Over time, everything should decelerate. But observations showed the opposite. The universe was expanding faster, not slower. Something was overpowering gravity on the largest scales. The only explanation that fit was empty space itself. The vacuum was not just fluctuating locally, it was shaping cosmic history. Its energy produced a gentle but relentless pressure, driving galaxies apart. Emotionally, this was destabilizing. The idea that nothingness could dominate everything else felt wrong. Matter built stars. Energy powered light. And yet, the emptiest regions of the universe were calling the shots. By this point, empty space was no longer a background detail. It was a central actor. The universe was not expanding into emptiness. It was expanding because of it. The force driving galaxies apart was not some exotic substance or mysterious field. It was the energy of nothing itself, distributed uniformly across every point in space and accumulating as space grew. The discovery that made empty space unstable had escalated. It was no longer about particles flickering in and out of existence. It was about the fate of the entire cosmos. The climax of this story is a reversal that still feels unsettling. The most influential ingredient in the universe may be nothing at all. Once this was understood, the vacuum stopped being an absence and became a presence. Empty space gained tension, pressure, influence. It quietly dictated how the universe would grow, stretch, and evolve over time. This insight reshaped cosmology. Expansion was no longer just a leftover from the Big Bang. It was actively driven. The universe was not coasting. It was being pushed apart by the energy of emptiness itself. More deeply, it reshaped intuition. Nothingness was no longer safe. Removing everything did not produce stillness. It produced activity. The universe refused to settle into silence. Today, this discovery sits beneath our understanding of cosmic fate. Whether the universe expands forever, tears itself apart, or slowly drifts into isolation depends on the behavior of empty space. Nothingness holds a final vote. The discovery that made empty space unstable was not a detail, but added a theory. It was a fundamental shift in how existence is understood. There is no neutral background, no true void. Even absence has structure. The discovery revealed that what we call nothing is in fact a rich, dynamic, and consequential feature reality, one that participates in every process and influences every outcome, whether or not we are aware of its presence. And once that is seen, the idea of nothing is forever changed. The universe is never empty. It is always doing something, even when it appears to be doing nothing at all. Subscribe to join the journey. The